first reason for diversity and magnitude of organic compound is catenation. Catenation is the ability of carbon atoms to link with other carbon atoms to form long chains and large rings. You can see over here in this figure, carbon atoms are linking with each other and they are forming a chain structure. This chain structure is a branched structure. Okay, so in this way, carbon is forming long chain of carbon atoms. The other example you can see over here, here carbon atoms are joining with each other to form a straight chain structure. In the same way, carbon atoms may join with each other to form rings of carbon atoms. So this ability of carbon atoms to link with each other to form long chains and large rings is called catenation. Now these long chains may be branch chains or they may be straight chain, and this adds to a number of organic compounds. Got it? Now there are two conditions for the catenation to occur. One condition is that the element should have a valency 2 or greater than 2. And the second condition is that bond made by the element with its own atom should be stronger than the bonds made by the element with other atoms, especially oxygen. Okay, in case of carbon, both the conditions are fulfilled. Carbon is having valency 4, so it can bond with the 4 other atoms. Second condition, the bond made by carbon atom with its own other carbon atom is much more stronger than the bond made by carbon atom with oxygen. That is why organic compounds are abundant in nature. Okay, in case of carbon, carbon can make up to 4 bonds and the carbon-carbon bond is a strong bond. That is why catenation is common in carbon. There are other elements also in group 14. You can see over here, if we compare the nature of carbon and silicon, that both belong to group 14. So both are having valency 4. So it means that silicon should also exhibit the property of catenation, but it doesn't. Why? What is the reason? Reason is the bond strength. Okay, you can see over here, carbon-carbon bond strength is 355 kilojoules per mole. Okay, but silicon bond strength is just 200 kilojoules per mole. In the same way, the bond strength of carbon and oxygen is 351 kilojoules per mole, and in case of silicon oxygen bond, the bond strength is 452 kilojoules per mole. That is why silicon occurs in the form of silica, sand and silicates in nature, and carbon occurs in the form of organic compounds in nature. Got it?